Before we get started thinking about products of vectors, let me make a quick note about a handy trick for understanding the direction of a vector, at least in the plane. So let's suppose that for some reason we need to find a vector v in the plane that makes an angle 3 pi over 4 radians to the positive x-axis and has magnitude 4. So 3 pi over 4 is going to be out this way some way, and we need to go 4 units. So it's going to be like this, but suppose we for some computation we actually need to know what are the coordinates of this vector, right? So the idea is, if we have seen that we can separate a vector into its magnitude and its direction. And for its direction, we're using the unit vector that points in the direction of the vector. So this here is a unit vector, right? Because we've divided out its size, so it has length 1. We know what we want the magnitude to be. So this part is just going to be 4. But then the question is, what is the unit vector that points in this direction, right? There's some unit vector that points in this particular direction. How can we find that? Well, the angle is telling us what direction it is. And if you think about just a unit circle, so this is too big to be a unit circle because I've already said this is length 4, but let me scratch that out. Now I can pretend that if this is a unit circle, remember that the position of any point on a unit circle is determined just by the angle that that point makes with the positive x-axis. So this point is the cosine of the angle, comma, the sine of the angle. So we can use that to write down a vector that points in the direction we want. So essentially we can just rewrite this but as a vector instead of as a point. So we can write this this vector, cosine theta, sine theta. So this points in the direction theta. Right, so we're going to plug in theta equals 3 pi over 4 in a second. But we do need to be careful about, well, is this a unit vector? Remember, what we really wanted was a unit vector. Well, let's compute the magnitude of this vector, because if it isn't a unit vector, then we'll just divide out its magnitude to get a unit vector that points in this direction. So the magnitude of this is, of course, the square root of the square of the first component plus the square of the second component. But wait a second, cosine squared plus sine squared is 1. So this vector here already has unit length. So this is a unit vector. Right? So the nice thing about sine and cosine is they produce a unit vector. All we have to do is feed the direction we want into this angle, and it will give us the appropriate unit vector. So to finish off here, right, we already knew the magnitude we wanted is 4. Now the unit vector we want is just cosine 3 pi over 4, comma, sine 3 pi over 4. And cosine 3 pi over 4 is what? Minus root 2 over 2. Sine 3 pi over 4 is root 2 over 2. And so we could leave it like this, or we could, I guess we could either factor out some constants or multiply out the scalar product one way or another. You get something like minus root 2 over 2, minus 2 root 2, or comma 2 root 2. Okay. Of course, it can be useful to go the other way. If you have a vector, you might want to know what a vector in the plane. You might want to know what angle it makes with the positive x-axis. So for example, what angle does this vector minus 2 comma 4 make with the positive x-axis? This vector isn't unit length, so this isn't immediate. We can't immediately write this as cosine of some angle comma sine of some angle. But if you just think about it geometrically, so minus 2 and then 4, up 4 in the y direction. So we're talking about this angle, or this vector here, and what we want is this angle Well, this is just like classic plane trigonometry kind of stuff, right? We have this distance is -2, this distance is 4. We want this angle theta, so we have an x and a y, and we want to know theta. We can use tangent, or arctangent, I guess. Arctangent of this, tangent of this angle theta is y over x, and so arctangent of y over x is going to be theta. So arctangent, we need arctangent of 4 over -2, so arctangent of 2, arctangent of -2, and then we can pull out a calculator. So let's make sure we're in radian mode like proper mathematicians, and do inverse tangent of -2. Okay, and this will give us our angle. It's -1.107, and this is in radians, although actually this angle is in quadrant 4, and we wanted an angle in quadrant 2, right? This happened because arctangent only ever gives you angles between -π/2 and +π/2. So if your angle is in the other half plane, you just need to add pi to it, or subtract pi to it, right? So we got this angle down, or this angle down here in quadrant 4, so we just need to add pi to sort of rotate that up to the quadrant we want. So add pi to that, and we get something like 2.0344.